Hi, welcome to Algebra 2 Common Core. Today we're going to be evaluating logs and solving log equations by rewriting our logs as exponential functions. So let's remember from our last lesson that when we have log to the base b of x equals y, we can convert this over to an exponential equation by writing it as begin at the base, so b, raised to the answer for the log, which becomes the exponent on the exponential, equals x. So we had lots of practice with that in our last lesson of converting between logs and exponentials. Today we're going to need to be able to do that to solve our equations. Let's start with a definition. Sometimes logs are written without a base. And when a log is written without a base, it is called a common log. We assume that the base of a common log is just 10. So when we have a common log, we don't have to write the base. We can just write it like this, log of x, with no base written in. So whenever there's a base missing, we assume that the base is 10. Now let's take a look at these first three examples. They're meant to show that when we have log equations, our variable can show up in three different places. The variable can be the answer for the log. The variable can be the number that we are trying to get by doing an exponential. Sometimes that's called the argument of the log. Or the variable can be the base. And the base then becomes the base of our exponential as well. So let's remember how to rewrite these each as an exponential and see if we can figure out what each x would be equal to. So in the case of the first one, I would rewrite this, and again, if it helps to draw those arrows, go ahead and do that. 2 to the x is equal to radical 2. So 2 to the x is equal to the square root of 2 would be our exponential form of this log equation. Now, as long as we can make the bases be the same, that's going to help us to find out what our x value is. So on the left side, this remains 2 to the x. On the right side, remember when we're trying to do a square root, that means exactly the same thing as 2 having an exponent of 1/2. Now when the bases match, we learned this in the last unit, then our exponents have to equal each other. So x must be equal to 1/2. So what that tells me in my log equation is that the answer for the log, this x, is equal to 1/2. Log to the base 2 of the square root of 2 is 1/2. 1/2 is the exponent I have to raise 2 to get a 1/2, to get a radical 2. Let's try number 2. So again, drawing in the arrows, I'm going to say 2 raised to the 4th is equal to x. This is a nice easy one to solve because the x is already isolated. So 2 to the 4th power, of course, is 16. So I get that my answer is x equals 16. So again, I would write that then as log to the base 2 of 16 does equal 4. So my answer for x is 16. For the third one, let's draw the arrows again. Beginning at the base, my base is my variable x. I'm going to raise it to the 3rd power, and I get that my answer is 8. Now most of us know what number we have to raise to the 3rd power to get 8. We all know that that's x equals 2. If we didn't know that, what we could do is take both sides and raise it to the reciprocal exponent of the x. So we would raise both sides to the 1/3 power. That gives us x equals the cube root of 8. And of course, the cube root of 8 is equal to 2. So in either case, I know that the x in this case is x equals 2. That's the base of my log. So let's go ahead and use this process to solve the remaining equations in this lesson. So for the first one, it says that we're going to be evaluating logs. So whether I have an x on one side or it just is written as log to the base 3 of 9, if you want to, you could fill in the x and say that I want to know what I have to raise 3 to get an answer of 9. So writing this as an exponential, of course, gives me 3 to the x is equal to 9. I think we all know that x is equal to 2. And again, if you didn't know that, we would write both sides of the equation with the same base. So 3 to the x is equal to 3 to the second power. So when the bases match, I know that my exponents have to be identical. So x must be equal to 2. That's just the answer for our log. For number 2, I'm going to write this as 10 to the x is equal to, now if I look at that decimal and I read it correctly, this gives me 1 over, this is 0.0001, so tenths, hundredths, thousandths, this is 1 1,000th. I'm sorry, 1 10,000th. So therefore, I see that I can rewrite this, and I've got 10 to the x is equal to 10 to the negative 4th power. So that tells me that x must be equal to negative 4 in this example. For the third one, writing as an exponential, I've got 8 to the x is equal to 4. And this one's a little bit harder to identify what that exponent has to be. So I'm going to go back to that method from the last unit where we write with common bases. So 8 is really 2 to the 3rd power raised to the x. 4 is really 2 to the 2nd power. So when I set the exponents equal to each other, because they both have a base of 2, I get that 3x is equal to 2, so x must be equal to 2/3. If I go back and check this, and I say, does 8 to the 2/3 power equal 4? The answer, of course, is yes, because it means take the cube root of 8, which is 2. 2 squared gives me 4. So this does check. Now, sometimes we're going to have logs given to us where they've got a coefficient in front. So we want to know, what should we do when we have that coefficient? And the answer is, first of all, let's evaluate the log. Don't pay any attention to the coefficient. So if I want to know the log to the base 2 of 8, I want to know what do I have to raise 2 to get an answer of 8. And of course I know that that answer is 3. So I'm going to replace log to the base 2 of 8 with the answer 3, and I multiply 4 times 3 to get a final answer of 12. So 4 multiplied by the exponent that I need to raise 2 to get 8. 4 times 3 is 12. For the second one, I want to know what exponent I have to raise 3 to get 9. So evaluating this log, 3 to the 2nd power is 9. If I then calculate by multiplying 5 times 2, that gives me a final answer of 10 for this expression. For the last one, I want to know what I have to raise 4 to get an answer of 1 over 64. Writing them both with the same base, 4 to the x is equal to 4 to the negative 3. So therefore that exponent must be negative 3. So the answer for the log to the base 4 of 1 over 64 is negative 3. I want to multiply by the coefficient, so 2 times negative 3 gives me an answer of negative 6. So don't forget the final step of multiplying by the coefficient. Now in part 3, I see that my variable has been moved to the argument of the log. So I want to know, I think this one is written incorrectly. So I'm actually going to just eliminate this example and go on to number 2. So we're going to say 3 raised to the negative 2 is equal to x. So therefore I'm getting that x is equal to 1/9. We should know that from our sprints. For the next one, 4 to the negative 1/2 is equal to x. So therefore I know that x has to be equal to 1 over the square root of 4. Remember, we say 1 over because I've got a negative exponent. Square root of 4 because my exponent is a fraction. So this answer for x turns out to be 1/2. Now in part 4, this time what's missing is the base of the log. So of course that'll also be the base of our exponential. So converting this to an exponential, I get x squared equals 100. What number do we have to square to get 100? I'm going to say x is equal to 10. Now technically we could also say that negative 10 squared gives me 100, but we're going to stick with our positive answer for x for our bases. For the second one, I want to say x to the 3rd power gives me 27. So what do I have to raise to the 3rd power? Must be a 3. If I didn't recognize that, again, what I would do is raise both sides to the reciprocal exponent. So 27 to the 1/3 means take the cube root of 27. For the last one in this set, x to the negative 3 is equal to 1/8. So I want to raise both sides to the negative 1/3, the reciprocal exponent. So when I do that, on the left side I'm getting x equals. On the right side, because my exponent is negative, I'm going to take the reciprocal of the base. So I'm going to say 8 to the positive 1/3 power. So therefore this means the cube root of 8, the cube root of 8 is equal to 2. Let's finish up our notes tonight by solving a little bit more challenging log equations. So again, when I see that I have a log equation, I'm going to rewrite it as an exponential. So I like to use these arrows. 10 to the 2nd power is equal to 2x minus 8. It's going to be really important that you understand how to do those conversions between logs and exponentials. Now, of course, we know that 10 to the 2nd power is 100. So 100 is equal to 2x minus 8. If we add 8 to both sides of our equation, we've got 108 is equal to 2x. Dividing both sides by 2, we get that x is equal to 54. Now we could, of course, go back and check our answer. When we do that, we're going to say log to the base 10 of 2 times 54 is 108. 108 minus 8, of course, is 100. Does that equal 2? Yes, of course, because 10 to the 2nd power does give us 100. Let's try the last equation. 4 is going to be raised to the 1/2 power and set that equal to x plus 3. 4 to the 1/2 merely means take the square root of 4. We all know that the square root of 4 is 2, so 2 is equal to x plus 3. So therefore, subtracting 3 from both sides of the equation, we get that x is equal to negative 1. And again, you can go back and substitute negative 1 in for x and see that we get 4 to the 1/2 is equal to 2. So that checks. I'm going to give you some you-try-its to work on. So once you fill in the examples into your box in your notes and then do the problems, come back and check your solutions. Please come back after you've tried these you-try-its and check your solutions with mine. Be sure to show all of your work for solving for each variable. Please check your solutions with the ones that I've shown here. You'll notice that on number 1, we rewrote that as an exponential. 5 to the x equals 1 over 25. The base of both sides could be written with a 5, so 5 to the x equals 5 to the negative 2. So therefore I know that the exponent must be negative 2. On number 2, writing that as an exponential, 3 to the x equals 81, but 81 is equivalent to 3 to the 4th. So when the bases match, the exponents have to be equivalent, so x must be 4. On number 3, we want to solve for the log first. So I rewrote that as an exponential, 1/2 raised to the exponent, I'm going to call it x, equals 16. Both can be written with a base of 2, so 1/2 is 2 to the negative 1 raised to the x. 16, oh, I'm sorry, I think I made a mistake on that one. 16 should be equal to 2 to the 4th power, so that would be positive there. So I get negative x is equal to 4, so therefore 3 times negative 4 gives me a final answer of negative 12. Sorry for that mistake about the sign. For number 4, x to the 5th is equal to 32. So what number do we raise to the 5th power to get 32? That has to be 2. And again, we could have raised both sides to the reciprocal exponent of 1/5 and seen that we needed to do the 5th root of 32. For number 5, 9 to the 3/2 equals x. Well, 9 to the 3/2 means take the square root of 9 and cube it. So that gives me 27 for my answer. And for number 6, that log equation, rewrite it as the exponential 8 to the 1/3 equals 3x minus 10. So I get the cube root of 8 equals 3x minus 10. We know that the cube root of 8 is 2. So add 10 to both sides of the equation to get 3x equals 12, and solve to get x equals 4. So let's do some more practicing with converting between logs and exponentials tomorrow in class so that we can be proficient at solving these log equations. Don't be put off by the fact that we've got this new notation of log. Just think about it as an exponent. Have a great night, and we'll see you in class.